trigonometric identities and equations. AS level maths again. Hope you guys are finding this useful. Drop us a like if it is, and let's begin. So we want to show that this annoying fraction is the same as this. You only want to work with the left hand side because you want to show it's equal to the right hand side. So you can kind of ignore it, but we want to use it partially, because right now we know the right hand side is all in terms of cos. That's all we need from it, and the left hand side is in terms of sine and cos. So first thing, let's get sine squared in terms of cos squared. So while you're practicing, write out your identities every single time, and you should know that sine squared theta is equal to 1 minus cos squared theta. If you skip this step, that's fine. But if next year you're struggling to remember identities, come back to this video and say, oh, this is why he made me do it. So please listen to the advice, just write it down. I know it's long this year, it will compound next year. So let's just substitute it straight in and stop waffling. So we can put it all in. It's all over this. Expand the top, so it's going to give us minus 10 cos squared theta, minus 7 cos theta, and then this is going to give us 10 plus 2, which is 12, and then 3 plus 2 cos theta. We can then factorize the top because we have it's a hidden quadratic, minus 10a squared minus 7a plus 12. So we are going to have 2 and 5. So let's write one of them to be positive, one of them to be negative, and then we're going to have 3 and 4. Cool. So I've just done that in my head. Let's just pretend you didn't just sit there and watch that happen. One thing that's likely going to happen is that and that are going to make up this. And you can check, because 4 times 3 is 12, minus 5 times 2 is minus 10. And what you're going to see happen is that if this factorizes like this, which it does, oh, that's not right, that's supposed to be 3 plus 2 cos. This and this can now cancel out, leaving us with that. So if you're running low on time in your exam, assume that and that are going to be the factorized form of this.